The goal of this video is to show you how to generate the printouts for comparing two independently sampled population means. So the goal is to take two different populations, mu1 and or population 1, population 2, and compare the means. In this problem, we're dealing with the spacing of lobster traps. There are two different cooperatives, the BT and the PA cooperative, that we want to compare trap spacing for. And so you can see in this particular data set, there's only 15 observations. But there are some that are from the BT cooperative and some that are from the PA cooperative. And we want to take a look at the mean distance between their lobster traps, say that better. You can see that we have a sample of each, 7 of the BTs and 8 of the PAs, and we want to look at these sample distances to see if there's a difference between the population means distance between the traps. So what we're going to do is go to our statistics, our 1-2 multi-sample test, and this is where we were, the one sample t-test if we were working with just a single population mean. But in this analysis, we want to compare two. So we go to a 2-sample t-test. Again, the label there, the t, typically we think it as small sample work, but this works for both large and small sample sizes. So we're going to go in there. There are, and I was in here just a little while ago, so I wanted to show you what it'll look like when you get here. There'll be no variables listed here when you first get in there. We want to look at comparing the mean distance between the traps, called trap spacing. The quantitative variable is what goes in as the dependent variable. We want to compare the mean of the trap spacing between the two cooperatives, and that's what we use as our categorical. So whatever the quantitative, the numbers are, puts it in as a dependent, and in the categorical, the two categories that you want to compare, that's the variable you use here for the categorical. Usually the value for the null hypothesis is 0. We keep that as 0. That's typically what's going to be there. And then you have to choose your alternative. If you want to detect a difference, you go to not equal to. If you want to show that one mean is bigger than the other mean, well, then you have to do a one-sided test. And I will say here, you got to be careful about the one-sided test. I'll come back to that in a second. Let's say I wanted to show that the mean of the BT cooperative was less than the mean of the PA cooperative. Let's say that was the hypothesis, that the mean of the PA was bigger than the mean of the BT. Well, when I say that the mean of the PA is bigger than the mean of the BT, that sounds like a greater than test. And hold on to that. I'll come back to that. So I'm just going to use a not equal to in this particular example, and we'll go and we'll look at what the printout looks like. It tends to be one of the more confusing printouts we run into. Here's the sample information up here. Here's the null and the alternative that I just specified. And then there's actually two different rows of information that are given here. You'll probably have a conversation about these two rows in your class as to which one is the appropriate one to use. But we'll take the test statistic. Oops, let's grab it here. The p-value, the confidence interval endpoints. They're going to be given in these particular columns. And that's how you generate the printout. Now, the conversation we were having a little while ago, or the discussion I was having a little while ago, about doing a one-tailed test. The thing that makes this tricky is when you generate these printouts, it's tough to know, and it's really not all that difficult, but you don't know initially, which is going to be considered the first group and which is the second. Let me go back to the data set. You see we have some BTs and we have some PAs. Now BTs are listed first and then PAs, but that's not the way statistics will think through it. It'll go and take a look at the levels or the values that are put in, and I want to come back to here, sorry. It's going to look at your cooperatives and it's going to take a look and it's going to say, hey, you know what, the cooperatives have BTs and PAs, and it's going to list them alphabetically. So even though BT was listed first here, on the printout the BT is listed first because B comes before P in the alphabet. And so it looks at them alphabetically and says this is the first one, that's the second one. Why that's important is because if you're doing a one-tailed test, if you want to show that the PAs are greater than the BTs in average trap spacing, in this case, because the PAs are listed second, you would actually have to do a less than test. That might be a little confusing for some. Two-tailed test, you don't even have to think about it. But if you're doing a one-tailed test, if I say test to determine if the mean of this group exceeds the mean of that group, don't necessarily put in a greater than sign. Consider which one's the first group and which one's the second group. If we want to show that the PAs have a bigger mean, we got to do a less than test in this particular example because PA is listed second. So hopefully that makes some sense to you. If not, talk to somebody that can help you in terms of coming to grips with it. This is the printout that we get. And that's generally the process you go through to generate a confidence interval or a test of hypothesis, in which case we use these guys for comparing two population means. Hope that helps. So long.